A quasar is an extremely luminous active galactic nucleus, in which a supermassive black hole with mass ranging from millions to billions of times the mass of the Sun is surrounded by a gaseous accretion disk. As gas in the disk falls towards the black hole, energy is released in the form of electromagnetic radiation, which can be observed across the electromagnetic spectrum. The power radiated by quasars is enormous. The most powerful quasars have luminosities thousands of times greater than a galaxy such as the Milky Way. The term quasar originated as a contraction of quasi-stellar radio source, because quasars were first identified during the 1950s as sources of radio wave emission of unknown physical origin, and when identified in photographic images at visible wavelengths they resembled faint star-like points of light. High-resolution images of quasars, particularly from the Hubble Space Telescope, have demonstrated that quasars occur in the centers of galaxies, and that some host galaxies are strongly interacting or merging galaxies. As with other categories of luminous active galactic nucleus, the observed properties of a quasar depend on many factors including the mass of the black hole, the rate of gas accretion, the orientation of the accretion disk relative to the observer, the presence or absence of a jet, and the degree of obscuration by gas and dust within the host galaxy. Quasars are found over a very broad range of distances, and quasar discovery surveys have demonstrated that quasar activity was more common in the distant past. The peak epoch of quasar activity was approximately 10 billion years ago. As of 2017, the most distant known quasar is Ulash J1342+0928 at redshift about 7.54. Light observed from this quasar was emitted when the universe was only 690 million years old. The supermassive black hole in this quasar, estimated at 800 million solar masses, is the most distant black hole identified to date. Quasars inhabit the center of active galaxies, and are among the most luminous, powerful, and energetic objects known in the universe, emitting up to 1,000 times the energy output of the Milky Way, which contains 200 billion to 400 billion stars. This radiation is emitted across the electromagnetic spectrum, almost uniformly, from X-rays to the far infrared with a peak in the ultraviolet optical bands, with some quasars also being strong sources of radio emission and of gamma rays. With high-resolution imaging from ground-based telescopes and the Hubble Space Telescope, the host galaxies surrounding the quasars have been detected in some cases. Quasars are believed, and in many cases confirmed, to be powered by accretion of material into supermassive black holes in the nuclei of distant galaxies, as suggested in 1964 by Edwin Salpeter and Yakov Zeldovich. Light and other radiation cannot escape from within the event horizon of a black hole. The energy produced by a quasar is generated outside the black hole, by gravitational stresses and immense friction within the material nearest to the black hole, as it orbits and falls inward. The huge luminosity of quasars results from the accretion disks of central supermassive black holes, which can convert between 6% and 32% of the mass of an object into energy, compared to just 0.7% for the pp chain nuclear fusion process that dominates the energy production in Sun-like stars. Central masses of 100,000 to 1 billion solar masses have been measured in quasars by using reverberation mapping. Several dozen nearby large galaxies, including our own Milky Way galaxy, that do not have an active center and do not show any activity similar to a quasar, are confirmed to contain a similar supermassive black hole in their nuclei, galactic center. Thus it is now thought that all large galaxies have a black hole of this kind, but only a small fraction have sufficient matter in the right kind of orbit at their center to become active and power radiation in such a way as to be seen as quasars. This also explains why quasars were more common in the early universe, as this energy production ends when the supermassive black hole consumes all of the gas and dust near it. This means that it is possible that most galaxies, including the Milky Way, have gone through an active stage, appearing as a quasar or some other class of active galaxy that depended on the black hole mass and the accretion rate, and are now quiescent because they lack a supply of matter to feed into their central black holes to generate radiation.